Okay, good morning children. We are back again with chapter 2, physics, class 8, physical quantities and measurement. I think last time for the video classes I have done till measurement of density of liquids. Today we are going to talk about relative density, though this is there in the book, but class 8 we do not go too much into detail. But I am going to introduce this concept to you because next day in class 9 we will be dealing with it at a deeper level. You'll be solving it more. You'll have to do sums and all. So if I tell you right now what it is, so it becomes easier for the next day. Okay. So if you go with the book that's been prescribed for you, page number 19, relative density. Okay. Now in this book it says those who have got the books, you can refer to that. There is a table on the table 2.1 where the density of aluminum is given as 2,700 kilograms per meter. That's the unit of density. Okay. Mass of volume. Okay. Density of aluminum is given as 2,700, and density of iron is also given 7,800 kilograms per meter cube. Ice is given as. Okay, so the book says from the table you will find that the density of aluminium is lesser than the density of iron, but more than that of ice. In other words, we can say that aluminium is lighter than iron, but heavier than ice. Okay. So as I told you what density is all about molecules. The more dense a substance, the more dense a material, the heavier it will be. Understood? So more molecules, because density directly relates to molecules. If molecules are there in a given area, if there are two substances and the area is the same, volume, everything is the same of the two substances, but one substance is heavier than the other, how does that happen? The substance which is heavier, its density is higher. What do I mean by density? I'm going to recap on this again. Density means number of molecules that's been packed in a given area. If the number of molecules is more, then the density is more. Then obviously mass will be more. For example, there's two buses. It's the same model, and let's say each bus will only accommodate 30 people, right? But in bus number 1, it is filled to the brim, 30. And in bus number 2, let's say only 15 people are there. Which bus do you think will be heavier? Bus number 1 will be heavier because the number of people in the bus is more than the number of people in the other bus. Understood? So we can relate density in these terms, right? So whenever we talk about density, this word is used in population. The density of population in a certain area is more than the density of population compared to another area. What do we mean by that? Population density means the number of people given in a certain area is more than the number of people in a similar kind of area, the same size area in another place. Understood? So that is what density is all about. So relative density again comes under density only. So it says out here, it will be practically impossible for us to memorize the density of each material to compare its density with another material. That's very true. How can you know that? Because whatever substance that you see in and around each other, for me right now, the book, my jacket, this dust, pen, table, this wall, everything has its own density. How to know? I don't know, you need to have a brain in which a computer has been fitted that you can know the density of each and every substance. Otherwise, you need to have a list of each and density of each and which is humanly not possible. It can be done, but it's a huge task and it's a very laborious task. Okay, that is why the concept of this relative density comes about. So, in order to avoid such confusion, scientists compare the densities of most substances to the density of water at 4 degrees Celsius. Why at 4 degrees Celsius? Because water is a very strange liquid. Okay, it was not there on the earth. There are many theories as to how water forms. Some say hydrogen molecules combined with oxygen molecules. When the earth was a ball of fire, there were so many gases in the atmosphere, and those combined and formed water. This strange two gases combined to form a liquid. Okay. Then there's another theory where water was introduced to the Earth when it was in its very early stages, when it was in its baby stages, in asteroids and comets and all these crashed on the Earth, and together with them they brought all the theories of them. But it's a very strange liquid, very very strange liquid. And they say water is an alien subject that was brought to Earth, because in space if you go, so you find a lot of ice, you find ice crystals and all those things. So that means space is littered with water actually, right? But water has got maximum density at 4 degrees Celsius. At 4 degrees Celsius. Okay? If you raise the temperature of water beyond 4 degrees Celsius, the density decreases because the volume increases. Similarly, if you lower the temperature of water beyond 4 degrees Celsius, again the density changes. What happens? Volume increases. A very strange phenomenon that we see on the Earth is icebergs. Right? Titanic, the movie iceberg caused the sinking of the ship. Icebergs float on water. Very strange. Whenever we have a liquid of a substance and we have a solid of the substance, whenever we put the solid of the substance in the liquid, the solid will sink. Why? Because density of that solid is more of the same substance, because the very fact it's in a solid state. Last time, as I told you about the previous chapter, intermolecular force of attraction, intermolecular space. Intermolecular space is very less. That means intermolecular force of attraction is high. That is why that substance is in the form of solid. So obviously, if density is high, the liquid density will be lesser than the solid density, right? Because liquid molecules are liquid, space dot volume is high. As we know from the formula, density equals to mass upon volume, right? Density and mass, they are directly proportional to each other. Density and volume are inversely proportional to each other. What do I mean by this? If mass increases, density increases. If mass decreases, density decreases. If volume increases, density decreases. If volume decreases, density increases. So these two are like friends, these two are like enemies, right? So this is the relationship between them. So liquid means the volume is more, so density is less, so it should sink. But in water, ice floats. So this is, there's a term called anomalous expansion of water. We'll come to that later on. But this is a very strange liquid. Water is one of the strangest liquids actually. Okay. So the densities of most substances to the density of water at 4 degrees Celsius, because at 4 degrees Celsius water has maximum density, minimum volume. Okay. This is called relative density of a substance. The relative density of a substance is defined as the ratio of the density of a substance to the density of water at 4 degrees Celsius. Another term used for relative density is specific gravity. Okay. So just the formula which is there. Okay. So relative density write this as RD for now. Okay. So relative density is density of the substance upon density of water at 4 degrees Celsius. Okay. Since density, as I told you, is mass upon volume. Okay. So density of the substance will be mass of the substance that we want to know about. Okay. Upon the volume of the substance upon mass of water at 4 degrees Celsius. H2O, I hope you know, is water. You should know by now. Okay, H2O, mass of water at 4 degrees Celsius. Volume of water at the same temperature. Okay. So let's say the volumes of the substance and the water are the same. So the volume will be cancelled out. So what remains in there? Mass of the substance upon, since volume being the same, some water. Okay. So thus the relative density of substance can also be defined as the ratio of the mass of the certain volume of the substance to the mass of the same volume of water at 4 degrees Celsius. As relative density is a ratio of the same physical quantities, it has no unit. Okay. So the relative density of a substance can easily be converted to the actual numerical value of the density by multiplying the relative density value with the density of water at 4 degrees Celsius. Okay. So I'll just give you this formula. We are not going to do any more sums. Okay. Just going to round this off. Not talking any of that. So density, relative density into 1 gram per centimeter cube, or RD into 1000 kilograms per meter cube. This is in CGS, this is in SI, standard. Okay, volume as well as cube, volume as well as meter cube and centimeter cube. Okay, so volume is 3-dimensional, length, breadth and height. Okay, so this is what you need to do. Just for your information, we will be using this concept later on in class 9. Thank you so much.